Hey, welcome back to your favorite Fundamentals of College Math class. We're going to look at triangles today. Here's our objectives. Let's start out with talking about, well, first of all, what a triangle is, where you've got a closed geometric figure, has three sides, all of which lie on a flat surface or plane. Let's take a look at a theorem. First of all, what is a theorem in mathematics? It's just a conclusion that's been proved to be true through some deductive reasoning rather than inductive. So a very formal process where you're giving the reasons based on previous theorems and assumptions. Um, so here's something called Euclid's assumption, and it just says given a line and a point not on the line, right? So you got a line, a point not on the line. There's only one line that can be drawn to the point given that's parallel to the given line. So, and Euclid, by the way, is he's a Greek mathematician about lived around 300 BC or so, and it's often referred to as the father of geometry. His book Euclid's Elements, which are based on um, some axioms and some assumptions, and then they developed the entire field of what's called Euclidean geometry. So, and it was used for hundreds of years, clear up until about the 19th century. One of the most influential books ever in mathematics. Well, Euclid's theorem says the sum of the measures of the three angles of any triangle is 180 degrees. So if we took that Euclid's assumptions, we put a couple points on that line and then connected it to that point B on the opposite line there so that we created a triangle here. So we have this triangle ABC. Let's see if we can deductively actually prove that the sum of the three interior angles of a triangle is 180 degrees. So first I'm gonna start off and say, well, first of all, we know since these are parallel lines, you know, we've got this line and this line parallel. If you look at this, this is like a transversal through there. So we know angle 1 is equal to angle 2 from last time by alternate interior angles. So angle 1 is equal to angle 2. We also know angle 3 is equal to angle 4. Again, we discussed last section. This is by alternate interior angles. Now, if you look at angles 2, 5, and 4, look at these right here. These angles 2, 5, and 4. See how they're on that straight angle there? So angle 2, angle 5, angle 4, they form a straight straight angle together. Sorry, I really struggle writing with these digital pens. Form a straight angle, hence 2, 5, and 4 must add up to 180 degrees. Well, we're trying to, if you remember, we're trying to show that these interior angles of a triangle all add up to 180 degrees. Well, we know, so where are we getting at here? If 2, 5, and 4 add up to 180 degrees, well, we know 1 and 2 are the same. So by substitution, I can replace 2 with 1, and I can replace 4 with angle 3. So angle 1 plus angle 5 plus angle 3, in other words, the interior angles of a triangle all add up to 180 degrees. That's just an example of deductive proof there for Euclid's theorem. Well, let's use that information here to find the measure of angle A for the triangle. So this angle A we don't know, so angle A, and we know the three interior angles of a triangle all add up to 180 degrees. Euclids Theorem. So let's go ahead and solve for angle A. Add those two up right there. And we've got, what's that, 43 degrees? 43 degrees. So that angle right there is 43 degrees. All right, let's find the measure of angles 1 through 5 here. The first thing I'm looking at is I'm looking at this right angle right here. And I notice, well, if that's 90 degrees, these are forming a straight angle. If that's 90 degrees right there, this angle 1 has got to be 90 degrees, right? Because 90 plus angle 1, and that right angle plus angle 1, 180 degrees. That angle 1, once we subtract 90 from both sides, that angle 1's got to be 90 degrees. Now I'm looking at this triangle right here. So I know angle 1 plus angle 2 plus angle 2 plus the 43 degrees. Those are three interior angles of a triangle. So they got to all add up to 180. And we know what angle 1 is. That's 90 degrees. Add the 90, 143. So 133 plus angle 2 is 180. Subtract 133 degrees. And so we've got angle 2 in 47 degrees. So now we know that's 47 degrees. Now angle 2 is the same as angle 3. Why? Vertical angles. Remember from last time. So these are the same vertical angles, these opposite angles, because we've got the two straight lines intersecting there. So since that's 47 degrees. So our angle 3 is 47 degrees. So now we have angle 1, angle 2, angle 3. Again, that's also 47 degrees. So now I'm looking at this triangle. So I know angle 3 plus angle 4 plus 60 degrees, all three inside of a triangle, those add up to 180. That's 47 degrees. Angle 3 was 47 degrees. So we have 107 degrees plus this angle 4 is 180 degrees. Subtract 107 on both sides. And we got angle 4 ends up being, what's that, 73 degrees. And then finally, look at angle 4 and 5 right here. 4 and 5 are on that straight angle. So 4 and 5 add up to 180 degrees. And we know angle 4 is 73 degrees. So subtract 73 from both sides. And we end up with 170 degrees. 107, I'm sorry, 107 degrees for that angle 5. That's just the work through there. All right, triangles and their characteristics. So we can classify triangles by angles, or we can classify them by sides. So if all three angles are less than 90, it's an acute triangle, right? So if all the angles are acute, if one of the angle measures is 90 degrees, like right here, we got a right triangle. If one of the angles is more than 90, of course less than 180, we've got an obtuse triangle. Now, if we classify it by sides, now if we have two sides that are equal, that's isosceles, just two sides that have equal length. And equilateral means we have three sides that are equal. Which also means if all three sides are equal, that means all the angles in there are going to be equal. And they must be 60 degrees if they're all the same. 60 plus 60 is 180. Finally, a scalene triangle means all three sides are different. Those are all different lengths. Scalene triangle. So similar triangles have same shape, but not the same size. So they have corresponding angles. Right? Their angle measurements might be similar, but the side lengths could be different or similar. triangle. So here's just kind of showing that. You see how angle A corresponds to angle D. So those maybe both of them are like, I don't know, 100 degrees or something like that. And then angle, let's see with the two marks here. So the angle C corresponds with angle F, and then angle B with angle E corresponding. And then look at the side length opposite angle A. So that 8 inches corresponds with the 4 inches. So BC corresponds with EF. BC corresponds with EF. AD AC would correspond with DF, and finally AB would correspond to AD. In other words, there's a ratio. So the ratio is enough there. Let me. If the ratio you'd set up is, it's an 8 to 4 ratio. That side corresponds to that side. It's 8 to 4. In other words, a 2 to 1 ratio. Notice 6 inches, 6 to 3 ratio, right? It's still a 2 to 1 ratio. 4 to 2 ratio. It's a 2 to 1 ratio, right? 4 to 1. Let's do some problems here. Find a missing length x. We're going to set up a ratio, and notice that they tell us right here this angle corresponds with that angle. So in other words, 8, it's an 8 to 5 correspondence here, ratio, right? So 8 is to 5 as, now the other one they don't show here is the vertical angles. So the side opposite the vertical angles, that's the 7. So 7 corresponds to the x, right? But now I went 8 is to 5. I went 8 is to 5, so I got to go with the larger x is to 7. X is to 7 when I set that up, right? 8 is to 5 as x is to 7. All right, you set up the ratios there, and then you go ahead and solve it. So you just cross multiply here. You can do this with when you got ratios equal to each other. 8 times 7, we got 56 equals 5x. And we solve for x. So we got 56 fifths, or let's see, what is that? 11 and 1/5, or 11.2. All right, the Pythagorean theorem. So the most famous theorem in all of mathematics is referred to as the Pythagorean theorem. You must have a right angle for this to work, and it says the sum of the squares of the legs. So a squared plus b squared equals the c squared equals the square of the hypotenuse. The hypotenuse is always opposite the 90 degree. The legs or the sides right next to the 90 degree angle. Okay. You can see it there with this one here. You've got a 3, 4, 5 triangle. And this is saying, 3 squared plus 4 squared must equal 5 squared for a right triangle, right? In other words, 9 plus 16 equals 25. You notice they're showing it to you. A 3 by 3. In other words, there's 9 square units in here. There's 9 square units. Let's say it's square inches. You got 4 by 4, 4 squared, right? We got 16 square inches. So the sum of 9 and 16 would give us the 25 square inches. 5 by 5, 5 squared. All right, let's go ahead and apply the Pythagorean theorem here. Find the length of the hypotenuse C in the triangle. We've got our legs here. So 9 squared. And by the way, the little a would be opposite the angle A. The little b, is commonly opposite the capital B, the angle B, right? So 9 squared A squared plus B squared equals hypotenuse squared. So 9 squared plus 12 squared equals C squared. So we got 81 plus 144 equals C squared. And let's see, what's that? 225 equals C squared. And then how do you solve that? Go ahead and take your square root on that. And that is 15, right? In other words, 15 times 15, you're looking for 2. Square root of 225 is 15. Punch it in your calculator. Well, thanks so much for listening. We will see you next time with our next geometry section.